All right, in the last lesson, we covered the first 5 fundamentals of computer programming that you need to know to begin your game development journey in GDScript and in the Godot game engine. In this lesson, we have 3 more to go. Let's go ahead and jump in with number 6, if statements and Boolean expressions. If I jump back over to Steve's code, I'll go ahead and click on the little script icon next to Steve. There are a few times in the physics process delta function, please recall that this is the function in Steve's code, in my character's code, that repeats or loops very, very quickly, in fact 60 times per second, where we have the keyword if. If is a keyword in most computer programming languages that lets you create a conditional statement where if a condition is met, you can execute what's called a block of code. Let's simplify this a little bit. In most computer programming languages, you can create what's called an if statement where you have 2 parts after the keyword if. You have the condition, which is what you're checking to see if it is true. This condition is actually called a Boolean expression. The word Boolean means true or false. And by putting the keyword if before the statement, you are checking to see if that event or statement is true. And if that expression, that Boolean expression, the condition is true, you will execute the lines of code below the if statement. What can we do with this? Well, the most simple example is if the human player is pressing a key on their keyboard, let's say the left arrow key on their keyboard, well, we want to make the player move to the left. Now, what I have on screen right now is called pseudocode. Pseudocode means just sort of code without proper syntax, just to illustrate the idea of an if statement with a Boolean expression, as well as a block, which will be executed only if the condition is met, only if a human player presses the left arrow key on their keyboard. In Steve's actual script, you can see that 60 times per second inside of my physics process delta game loop, I have an if statement here that says if not is on floor. Well, I'm pretty sure you can guess what this method call does. Is on floor is a function. Actually, it's called a method because it's built into our character body 3D object in Godot. Is on floor is a method that it checks to see if your little player is touching, well, the floor, based on the idea that floors are solid block objects that your character hits as they move downward and they can land on it. So if the character is on the floor, this method returns to our code true or false, which we are inverting with the keyword not. So if we are not on the floor, then we will do this block of code, which will make us fall with gravity. You can see that this keyword velocity, which is actually a variable that is built into our character object. We don't have to create this variable. It's built into our character body 3D object without having to actually make it or type it for ourselves at the top of our character code. It's built in. And this velocity variable has actually 2 parts. It's actually a multi-variable variable. It has an x value as well as a y value, and we're telling the velocity y value to change with gravity 60 times per second. I'm not going to go into the details of what delta means quite yet. Right below that, we have a second if statement. We have if input.isActionPressed UI accept. This is Godot's fancy way of saying if the user has pressed the space bar on the computer keyboard, well, this event might happen. We might make our character jump, but in fact, 2 things have to be true. So this condition is actually in 2 parts, which is called a compound Boolean expression, because both the condition that the user is pressing the spacebar on their keyboard and the condition that they have to be on the floor, both of those independently are true or false expressions. They can both independently be true or false. They both have to be true in order for this block of code to actually execute. Speaking of that word that I just used, block, this block of code, you'll notice, is indented 1 extra time. An extra tab was pressed because we indented in our physics process delta function. So inside of our physics process loop function, we have a block of code, which is indented once from the very left side of the code editor, where you can first type text against the very left side of the text editor. We have 1 tab to denote that this is a block of code. Everything that I have selected right now on the screen is a block. But then we're indenting one extra time under the if statement to denote that this is also a block of code that will only execute if the above two conditions are both true. One last thing before we actually try typing an if statement for ourselves in our own icon code, and that is this third if statement, which says if direction. A couple of things here. Number one, what is direction? I thought that you had to put a Boolean expression, a true or false statement after the word if. How is this word direction true or false? Well, if I jump back into my icons code, I'll click on my little script icon right here. I told you about several types of variable data types in the last lesson. There is one that I omitted, and it is now very prevalent to what we're talking about. We can make a variable on the next line of our icons code called var, and I'm going to name this variable is Godot awesome. Well, this variable is not going to hold an integer. It's not going to hold a floating point number with decimals. It's not going to hold a string. It's going to hold, I'm going to assign it a value that's either true or false. If I type the word true here, T-R-U-E, this is actually a valid variable declaration as well as a variable initialization. That means we're giving the variable an initial value because I have now made this variable a Boolean type variable. Recall that word Boolean, it means true or false. Well, you might want to keep track of something in your game using a variable that's either true or false. Let's say that you're making a game in Godot, and at some point in your game level, your character stumbles upon a key. This key is a collectible object, and if you've collected the key, well, later on in that same level, you might be able to unlock a treasure chest or perhaps a door. But you can only open that door or that treasure chest if you have that key. How would you remember in the game programmatically if you had collected the key or not collected that key earlier on in the same level? Well, what you might do is you might create a variable, I'll type it right here, called key underscore collected. If you've collected this key, then you can unlock that door or that treasure chest, but if you haven't collected that key, then you can't. This would be a perfect opportunity to use a Boolean variable. If you have not collected it, that means the variable could be false. And then when you actually touch that key to collect it, maybe that key deletes itself from the game level. Once you've touched it, it should probably disappear. But then a variable on your character's code would change like key collected from false to true. And therefore, when you go and touch that door or that treasure chest, then it would check to see the status of that variable key collected, and then it would open the door or do whatever it needs to do. In the case of Steve's code, my character's code, it is checking to see if a direction Boolean variable is either true or false, which in itself is a Boolean value or a Boolean expression because it's a Boolean variable. And if direction is true, well, it's doing some lines of code. And the last thing I need to touch on before we actually type some code for ourselves is this keyword else. Else is a catch-all statement that if an if statement is not true, and it does not execute the block of code, which would be a result of that condition, it does the else if the if was not executed. So you can have a do this if something is true, otherwise do the other option, the default otherwise code. So you can think of this word else as otherwise. It will only execute the else block of code if the if did not come true and it did not execute that block under the word if. Okay, let's actually go ahead and try typing some of this for ourselves. So I'm going to go ahead and jump back into my icons script. Now, if you recall from the last lesson, in my 3D world, I have this 3D sprite, which is just a flat picture, which is our Godot default icon, which Godot gave to us when we made a new Godot project. This 3D sprite is just sitting in our 3D world. And right now, if I select my level 1 scene and then I press play scene, what's happening with this sprite? Well, it's spinning in midair. It's not a physics object. It will not interact with anything else in the scene. It's just a visual instance of a spinning picture in my world. What I'm going to do in this lesson right now is in that icon's code, I'm going to write an if statement, which is going to be executed or checked 60 times per second to see if the user is pressing a key on their keyboard. And if so, we're going to make that icon spin in one direction or in the other direction. So in our function called process, which is our 60 times per second game loop, I'm going to go ahead and click right after the word delta and that little colon there. And I'm going to press enter to make sure that I'm indented the right amount of one tab. And I'm going to type the word if. I'm going to write a conditional statement that is built into GDScript to check to see if a keyboard key is pressed. How do you do that? Well, you type the word input with a capital I, input, and then dot, and then is underscore action pressed. Now you can see lots of options here. It's auto-completing what I could type that would be valid. What I'm going to do is press the down arrow key on my keyboard a couple of times to select the is action pressed option, not those two above it with the word just in it. We're going to choose the third one here and press enter. Now we want to tell Godot what action we're checking for. Godot has these things called actions, which is essentially a way of you giving keyboard keys names called actions. The one that we're going to check for is, well, the left arrow key and the right arrow key. And we're going to type the action name that's built into Godot for one of those keys. Let's go ahead and do the left arrow key first. If I say UI underscore L, it will show me UI underscore left, and I can simply press enter to autocomplete that line. This is now a valid Boolean expression. The user is pressing the left arrow key on their keyboard or they're not. It's a true or false check. When you're writing an if statement, you have to end that first line with a colon and then press enter. When you press enter, it should automatically indent you one extra tab here so that you're indented one more time below that word if. Okay, so you should have two little icons here. If I'm pressing the left arrow key on my keyboard when I'm playing my game, what do I want to have happen? Well, I'm going to make the little icon spin to the left using that speed constant that we set up in the last lesson. So I'm going to type rotate underscore Y. I'll go ahead and type the beginning of that, press down arrow a few times and press enter to complete that line. We're now calling that rotate Y function, but just like in the last lesson, we're going to call the degrees to radians function and convert our number of degrees, which is 2 degrees, into radians before we tell our sprite to rotate in that number of radians. But we're going to think in degrees here because degrees, I think, is easier for most of us to understand. So I'm going to call that degrees to radians function, and I'm going to give it our speed. Now, our speed is 2. And we could easily make it -2 or +2 to rotate left or rotate right simply by putting a negative sign before speed, making it -2, or if we didn't have that negative sign there, it would be +2. In this case, I think I will do negative speed. Next up, if I'm not pressing left, I'm going to assume the user is pressing right. So I'm going to simply replace this line of code here. I'm going to make another if statement right below the first if statement, indented the same as the beginning of our first if. I'm going to say if input dot is action pressed. I'll do this a little bit quicker this time. And I'm going to say UI underscore right. I'll put my colon at the end of this line. And I'm going to be a little bit lazy here. I'm going to copy and paste the rotate Y line and make sure I exactly have it tabbed in 2 times before I paste the same line and then remove that negative sign. So I'm rotating to the left or right, hopefully. I might have to switch those negative signs around, but I will do a Control S to save. And with my level 1 scene tab active, I can press play scene. And now hopefully if I press the right arrow key, I am rotating to the right. And if I let go, it doesn't do anything because I haven't told it to do anything if I'm not pressing any arrow key down. And if I press to the left, it rotates to the left, left, and right. Hey, I've got some interactivity in my game when it comes to that sprite. Now, you might have also noticed that my little block, my actual character, fell off the side of the floor because he is also controlled by the arrow keys on my keyboard. Don't worry about that. We're not going to keep this sprite in our game. This is simply for an example. However, we have a little bit of inefficiency in our code. We have two if statements back to back that are constantly being checked again and again, even though we know that the user is probably going to either only press one key, the left key, or the right key, and they're probably not going to press both left and right at the same time. At least we'll pretend that's the case. If the user right now is pressing the left arrow key, well, it's making our character, our little sprite, rotate to the left, and that's great. But if that's true, we probably don't want our computer to also then check if the user is pressing the right arrow key as well. They're going to press left or they're going to press right, and not both. So if we know that they're pressing the left arrow key, why are we then even bothering to check to see if the user is pressing the right arrow key at the same time? We shouldn't. We should probably just skip over that check if we know that they're pressing the left arrow key. If we want this to be the case, where we optimize our code so it's not checking both at the same time, at least some of the time, we can use that word else. We can say else space if. Now, this is actually not proper GDScript code. In GDScript, I just want to illustrate, we're going to shorten this in a sec to make it a little bit more valid, but I want to illustrate the point here. If the user is pressing the left arrow key, we want the icon to spin to the left. However, we only want to check then if they're pressing the right arrow key if the first statement is not true. So we're using that keyword else next to the word if because we only want to check this if statement otherwise if the first if was not true, if the first Boolean expression was not true. Hopefully you understand that logic. What I'm going to do to make this actually work is GDScript as well as Python coders are a little bit lazy here. They don't use the word else and the word if. They simply use the word elif. Elif is a combination of else and if. Let's go and see what that does. I'll press Control S to save. And with my level 1 tab active, I'm going to press play scene. And now if I press the left arrow key on my keyboard, it rotates to the left. If I press the right arrow key, it rotates to the right. And the program is a little bit more efficient than it was with just two if statements, now that I have an if as well as an else if. Okay? Next up, writing functions. Hopefully by now you're getting to understand that in our Steve's code at least, I'll go ahead and switch over to Steve's code right now. You can see that a lot of our game's logic, things that we're checking 60 times per second, is going to be the majority of our code. You can see lots of lines of code inside of this physics process delta function. But one thing that you need to understand is that you should probably try to subdivide up your code into more than just two functions in your one code file. Right now, if I jump back into my icons code, you can see I have two functions that we can actually edit and write ourselves, which are ready and process, which run at the beginning of our game when this object loads into the game when we press play scene, as well as 60 times per second. But we can actually create our own functions with names that we decide, and that will help us to segment up our code into little reusable chunks, which are essentially themselves little mini subprograms within our larger program that we can call whenever we want. Let's go ahead and write a few silly functions before we actually do something a little bit helpful for us in our actual icon code. I'm going to write a function at the very beginning of line 22 here. It doesn't actually matter that it's line 22. It matters that it's at the very beginning, at the very first character of this line lined up with the other word function. So I'm going to type that same keyword, func, and I'm going to make a little function called minion. Minion is going to have one little job to do whenever we call upon this minion. This minion is going to say banana. It's going to print out the word banana whenever it is called to the output dock. You see, I'm doing a silly example here to get us going into writing functions. Here we go. Whenever you create a function, you have to use the keyword func. You have to give this function a name. You need to put round brackets because sometimes functions can be designed to accept arguments or parameters. In this case, minion doesn't need to know anything to say banana, so we're not going to put anything in there, but we have to have those parentheses written there, just like that. I'm going to type a colon at the end of that line, and I'm going to press enter. And when you write the contents of a function, they need to be a block, which means they have to be tabbed in one extra time after the colon. So this line has an extra tab in it right there. Using print, he's going to say banana, like that. Okay, so now we have this minion. It's a little program, a subprogram inside of our big program that should run when it's called. Right now, if I save this code and with level 1 active, if I press play scene, are we getting any bananas? No, we're not, because a function needs to be called. It needs to be told to run, with the exception of the ready function, which automatically gets called when you start your game, and the process function, which runs at 60 times per second. Any functions that you create yourself need to be called. If I call minion inside of this ready function, if I type minion and then bracket bracket like that to call a function, you need to put the parentheses after the name of the function. If I save that code and then I press play scene, can you predict what will happen? It said banana right when the game first loaded, because it executed all of the lines of code inside of minion by our calling of minion itself right when the game first loads from our ready function. If I replace that call with the keyword pass, and then I put a call to minion in my game loop 60 times per second, minion, and I do a Control S to save, and I press play scene, can you predict what will happen? Well, it's printing out banana 60 times per second because minion is being called upon 60 times per second. Now, we can make functions like this that are just silly, but let's actually go ahead and make a function that is a little bit more advanced. Let's go ahead and make a function. I'm going to press enter at the end of this line and then backspace to put my cursor at the beginning of the next line, and I'll press enter just to space them out a little bit. I'm going to make a function called add these numbers. And when you make a function, you need to put round brackets and a colon, and you need to put some content in the body or in the block of that function. For now, I'm just going to type the word pass because I'm going to make this function accept some arguments or parameters. I'm going to, in these round brackets, make a couple of variables that will allow this function to accept data for it to work with. So I'm going to type in 2 variable names that I get to type right here and make up the names of them for myself. I'm going to type in x, a comma, and a space, and y. We're going to design this function to accept 2 different numbers, x and y, and we're going to make this function add those 2 numbers together. So instead of this word pass, which is just a placeholder, in GDScript you have to put something in a function. You can't just leave it empty. If you left it empty, it would complain at you, I think. Yeah, I'm getting an error. So I'm going to make a variable here called var sum, and sum is going to equal x plus y. Now that we've had this function calculate the sum of x plus y, in other words, we're taking x plus y, adding them together, we're assigning it into that sum variable, so it will store whatever x and y are together equal to when they're added together. We're then going to use the keyword return. We're going to take that sum variable, I'll type it right there, and give it back to our code wherever we called add these numbers from. If I call this function, add these numbers, from my ready function, so I'm going to call it from here, I'm going to say add these numbers, and I'll use that handy autocomplete and press enter. I have to give it 2 values. I'm going to say 5 and 6. When I put these 2 numbers in here, they will get sent to the add function and get stored in the same order that they were sent in and stored inside of these x and y variables. When that happens, it will add 5 and 6 together, store those numbers added together, which is 11, into sum, and then that number, 11, will get returned back to our ready function. Right now, we're not having it actually save that number 11 or do anything with it, so we're not going to see anything. In fact, I'll try running this code just to make sure I haven't made any mistakes. I'll press Control S on my keyboard, and with level 1 active, I'll press play scene. Well, we're getting banana 60 times per second. Maybe I'll go ahead and comment that out. By the way, if you don't want a line of code to run and you want to quickly comment it out, therefore, you don't have to manually type a hashtag to comment it out. You can simply click anywhere in that line and you can type Control K. Control K will add that line to a comment by putting a little hashtag at the beginning of it. Or if you type Control K, it will get rid of a hashtag that you put there in the same way. Okay, so I'm going to comment out that minion call so it's not printing out banana a bunch of times. So I'm going to press Control S to save. I'll press play scene. And now it does nothing. What can I do with that number 11 that I just calculated? Well, I can print it out. I'm going to call right here that print global function, and I'm going to add these numbers into the argument or parameter of the print function call. So I'm going to put an extra round bracket at the end here because I want to call completely, including the 2 round brackets, add these numbers, and then when we get a returned sum, it's essentially going to put the number 11 right there, and it's going to print out 11 because it got that value back from the function add these numbers. I'll go ahead and press Control S to save, and with level 1 active, I'll press play scene, and hopefully now I get 11. Pretty neat. If I go ahead and change those numbers, of course, if I'm calling add these numbers with 5 and 6, if I say 11 and 14, hopefully you can predict what that would print out. If I do a Control S to save and press play scene, you can see get printed out the number 25 into the output dock at the bottom. Okay, so that's how you write a simple function called minion in this case, as well as a function that's a bit more advanced that accepts data and returns data to where it was called from. Okay, how can we actually use this in a somewhat practical way? Well, I'm going to actually take these 4 lines of code out of my process game loop function because, like in my Steve code, I don't want the physics process block of code to get too long and unwieldy. If your code gets too long in any one section of your code, it gets a little bit much. So I'm going to go back to my icons script, and I'm going to take this code and I'm simply going to cut it, and I'm going to make, and I'll put pass there actually for now, and I'm going to make a new function called func check inputs. And I'm going to design it to not accept any arguments. I'm going to put a colon at the end of that line. I'll press enter, and I'm going to paste what I just copied from process, those 2 if statements or if and else statements, just like that. When you paste an if and an elif, make sure that it's tabbed in once in the function block of code, and make sure that it didn't get messed up by extra tabs getting put in there. Sometimes you might find that it might put extra tabs there, and that would not work. So make sure that it's lined up properly like before. But now that we have this check inputs code separated out so that our process game loop isn't too crowded, I need to still check these things 60 times per second. So I'm going to simply call check inputs with round brackets 60 times per second to do the exact same job, but separated out into its own function. So I'm going to press Control S to save. With level 1 active, I will press play scene. And now we can press left and right to make our little icon spin left and right. It works exactly the same. There we go. Lastly, objects, inheritance, and documentation. There are a few big ideas I want to finish off this lesson with, and hopefully these last few points will point you in a very big direction to be able to discover new parts of GDScript and how to use different objects and their methods on your own without exactly following me step by step. One of the big ideas I want to finish off with is the idea that every single node that you add into your game project in Godot, in other words, all of these different node options, all of the ones that you can find under the scene dock, under the plus button, when you go and add a new node into your game, these are all objects that are written as their own separate code files called classes. And classes can have their own variables in them, as well as their own functions called methods when they're inside of a class, like any of these types of nodes. And being able to understand this big idea of how code is organized, how do I know that there is a method called isOnFloor that I can use when I have a character body 3D object in my game? Well, what you can do in the code editor in Godot is if you hold the control key down on your keyboard and you hover your mouse over any of the keywords like a function name called isOnFloor. If you hold Control and you click on that name, you will open up Godot's extensive documentation exactly to where the written description of that function or method is. You can see that when I held Control and I clicked on isOnFloor, it's jumped me into the documentation of, if I scroll up to the very top of this document, to that character body type of object in the Godot documentation. And if I go ahead and open up this little side panel, I'm not sure why I had that hidden in the first place, but the side panel in the script workspace in Godot shows you a list of all the code files on the side that you've been working on, so you can quickly jump between them. I've got my icon.gd as well as my Steve code, which actually I've gone ahead and edited because I can see there's a little asterisk there, which means it's been updated and not saved. So I'll press Control S. You can see that now I have my documentation also open for this type of character body 3D object. And if I go back to Steve's code and I click with Control held down on that isOnFloor method call, you can see that it jumps down in my character body documentation page exactly to where that isOnFloor is documented, and I can read about it. I can see that it returns true if that body, our character Steve, collided with the floor on the last call of move and slide. Otherwise returns false. The up direction and floor max angle are used to determine whether a surface is a floor or not. So you can see that there is a whole page that describes every little part of how you can use a character body 3D object. And there is a documentation page like this for everything in GDScript. So if I go back to steve.gd and I hold Control and I click on isActionJustPressed, it's going to jump me to the input class down to that method called isActionJustPressed. And of course, I could read all about it right here. If I go to my icons code, which we typed almost entirely by ourselves, you can see that we used a method called rotateY. And this method, of course, is something that we can call with a sprite 3D to make it rotate on the y-axis by giving it a number of radians by which it should rotate 60 times per second in our process game loop. If I want to see what else I can do with a sprite 3D, which is what my icon is, I can go up to the top of my icons code where it says extends sprite 3D, and I can hold Control and click on that type of node name, sprite 3D. When I do that, I can see all the types of properties, which are variables that I can access and perhaps change about my sprite 3D. I can access a variable of my sprite 3D called frame coordinates, horizontal frames, etc. However, you'll notice that if I scroll through the documentation for this sprite 3D class, that there isn't a method listed called rotate_y. So how are we able to use in my icon code rotate_y as a method call if that method doesn't exist in this sprite 3D class? Well, it turns out the answer to that question is that every type of node in Godot pretty much inherits other properties, in other words, variables, as well as other methods from other types of nodes or classes in Godot. You can see that this sprite 3D node inherits the code. That means all of the properties or variables, as well as many different methods from other classes, like a class called Geometry Instance 3D. If I click on that Geometry Instance 3D, it itself has lots of different variables built into it, and we can see that this class happens to have a few methods built into it, which we could call from our sprite 3D because sprite 3Ds inherit everything from this class called Geometry Instance. If I keep going down the path of nodes that are inherited by this class, which means they're also inherited by Sprite 3Ds, there is a class called Visual Instance 3D, which has its own variables and methods. And if I keep going down this path to Node 3D, which is also inherited by lots of other different types of nodes, including Sprite 3Ds, I can see that there are a lot of different variables here, as well as many, many different methods, including the one called rotate_y. If I click on that name, it'll jump me or scroll me down in this document down to its definition. This method, which is called rotate_y, rotates the local transformation around the y-axis by an angle in radians. This method requires one argument, an angle, which is a float number, which is a number that can have decimal points. And this keyword void means that this method doesn't return anything. You simply call it and it does its job. It rotates that object in your scene on the y-axis. If you end up having lots of different documents open at the same time, like me, you can right-click on any one of them and say close. And if I only want to have my active GD code files open, which I'm actually typing for myself, I can simply right-click on each one and say close. I'll do that very quickly. There we go. If all that documentation is a little bit overwhelming, I don't blame you. Don't worry about it. If you want to ease yourself into Godot's documentation, I recommend that you simply go ahead in any code file and click on this link to the online documentation. If you do that, your default web browser will open to this very page. And as long as it's not too narrow on your screen, you'll see a sidebar where you can look up documentation and introduction. There's a section called Getting Started, which has tutorials that you can check out there for yourself as well. But I think that's going to be it for this lesson. As always, thank you so much for watching. I'll see you in the next one. Bye-bye.